this problem is to find the next greater element. So what you have given us, so the next greater element of some element x in an array. So some element x in an array. So next greater element is the first greater element to the right of x. So the first greater element to the right of x is 4. So 4 is the next greater element to 3. Even though 5 can come here, but 4 is the next greater element. Okay. Now you are given two distinct arrays, nums1 and nums2. Okay, where nums1 is a subset of nums2, which means that all the numbers in nums1 will be in nums2, but need not be in the same sequence. Okay, and so what you have to find is, for every element here, you take, that should be an element here, right? So they take the element here and you have to find the next greater element and put it in an array. If there is no next greater element, you have to put -1. So suppose you take 1, for 1 the next greater element is 3, so you have to put 3 here in the resultant array. For 2, there is no next greater element, so it should be -1. Okay. So now what is the logic here? So you need to find the next greater element. So ideal thing is to have a stack. First thing, you have to find the next greater element of all this, right? So grow from here. Okay. So you are taking 2. You are checking the stack. If the stack is empty, then there is no next greater element of 2. So for 2, you put -1 in a hash map. So you need a stack, and you also need a hash map to note down what is the next greater element of a number. Okay, then you go to 4, you see the stack is empty, now you put 2 here. You find the next greater element is null, you put 2 here. Now you come 4, now comes 4. Now when it comes 4, right, you check the top of the stack. If the value is 4 is coming, right, if the value is greater than 4, then there is a next greater element. Here it is not, it is less. So since it is less, you have to remove it from the stack. Once you have to keep on removing, right, until you find the next greater element. There is no next greater element, the stack will become empty, and for 4 also it put -1, right? And then you go to 3. So if 4 you put -1 and put 4 here, and you get 3. When 3 comes here, right, you see the top of the stack is greater than 3. So for 3, the next greater element is whatever is there in the top of the stack, which is 4, right? And you put 3 here. And then next comes 1, you go, you check the top of the stack, the value is greater than 1, so for 1 it is 3, and you put 1 here. Okay, so basically you are using a stack to find the next greater element, right? Suppose after 1, if some 5 comes here, you are trying to put 5, right? Now you see this is greater than 5, no, remove it. This is greater than 5, no, remove it. This is greater than 5, no, remove it. Now the stack becomes empty. So for 5, you put -1. Right? So you use the stack to do it. Now let's see how to code this. So we need to declare a hash map. Hash map will have integer as key and integer as value, right? Next greater element only you have to find, right, for all this. So both are things. We have a HM, we call it a hash map, new hash map. Okay, so you have declared a hash map, and next you have to declare a stack. Stack is integer which equal to new stack. You have declared a stack. So now what you have to do is, you have to traverse this array from the left, correct? So now first for that we find the length of the nums2 dot length. Okay, and now you have to traverse from the back. Okay, len is greater than I is greater than or equal to 0. Okay, so for everyone you have to find, now you have to go for I minus minus. Okay, good. So this is a loop which you are traversing from 2, right? You are going backward. Now what you have to do is, when a number comes, okay, what number comes, You have to go and until the stack has a number, right? Which is you have to keep on popping from the stack, correct? Now, what happens is, right, in our case, when in the stack you had, in the stack, right, in the stack you had 4, 3 and 1. Now, when 5 comes, if the stack is not empty, right, and the top of the stack, right, is less than this number, you have to keep on popping from the stack, right? So for that you need to loop. So what is the condition? While your stack dot is empty, right? If it is not empty, and stack dot peak, the top of the stack, peak will not remove the element, you will see the element. This is 1. If it is less than the number you are seeing, nums2 of I, this is nums2 of I, right, which is 5 you are seeing, right? Until then what you have to do? Until this condition is true, you have to pop from the stack. And that's what you have to do. Simple. Correct. Now you have done this. Okay. Now what is the thing? In this case, if the stack is not empty, okay, now you keep on popping. Now if the stack is not empty, now in this case, right, for what happens is, consider the case where 1 comes. Now when 1 comes, stack is not empty, that's fine. The peak is 3 and the number is 1, which is not less. So you are not going to pop anything. And the stack is not empty now. So the top of the stack, right, the top of the stack will be the next get element of 1, correct? So that you can put in the hash map. So the hash map dot put for the number coming, nums2 of I, for 1 is what is coming here, right? So nums2 of for 1, what is the next get element? What is there in the top of the stack? This is the next get element, correct? Else, if the stack is empty, hm dot put for nums2 of I, what is the next get element? -1, correct? So after that you have to push your value to the stack. If it is confusing, you can also have a variable for nums2 I. What value you are pushing, right? The nums2 of I. You can also put in a variable, but that is not required. So I put it here. Correct? Now I have populated my hash map, right, for all these values. Right? Hash map is for this hash map is populated. Now I have to return in an array. Correct. So I will declare a resultant array is equal to new integer array of nums1 dot length. Correct. So in nums1 only, for the values in nums1 only, I have to find the next get element. Okay. So the same size only this is also going to be. Okay. Now I will loop through all the elements in nums1. Nums1. Okay. Now I have to put it here, right? I need to have a variable for this. Otherwise I can use a variable. I can use an index itself. I will use the index itself here itself, so it will be simple. I less than nums1 dot length for all the elements in nums1. Okay, what I have to do, I have to find the corresponding next get element. The next get element is there in the hash map. So hmap dot get of that particular value for nums1 of I. Because I have already populated that for 4 what is the next get element, for 1 what is the next get element, I have already populated in my hash map. So this is updated. Finally I return the rest. Let's first build it and see. So time complexity is, we are using this hash map, right? So this hash map stores the next get element of all the elements in nums1. So space complexity is order of m. M is the size of nums1. Okay, nums2 size of nums2 is n. Okay, and this loop is running for size of nums2. So this is order of n time complexity, this loop, and this loop runs for nums1 length. So this is order of m time complexity. So m plus n. M is the size of nums1, n is the size of nums2, and the space is order of m, size of nums1, because that much entries you will have in the hash map.